Our next experiment is Z parameters. So it's mean experiment on a determination of Z parameters. So here Z parameters, in the sense we are calculating the impedance values. So that impedance values we are calculating based on the voltage and current, because resistance R is equal to V by I. It's mean we know the voltage and current, in the sense it is very easy to calculate the resistance. So that resistance we can replace with impedance. Okay, so impedance Z we are calculating here by using two-port network. So here this one is a two-port network. So for the two-port network, the input and output voltages V1 and V2 can be expressed in terms of input and output currents I1 and I2 respectively. So here we have two voltages, one is a V1 and another one is a V2. So we are taking V1 at one end, it's mean as a input, and V2 as a output, or otherwise V2 as a input at second port side, then V1 as a output. So here already we know that V in the sense V1 and V2, and Z place we can take here four parameters, Z11, Z12, Z21 and Z22. We are calculating this Z11 and Z12, Z21 and Z22. It's based on the open circuit calculations. So impedance we are calculating based on the open circuit. So here the Z parameters completely we are calculating by using the open circuit method. Okay, so why we are calculating Z parameter by using impedance, open circuit method, in the sense it's very simple. In open circuit condition, voltage is very high and current is almost zero. So here V1 and V2 are input and output voltages, and Z is a impedance of the network, and I1, I2 are a input and output currents. So already we know that these two equations, V1 is equal to Z11 I1 plus Z12 I2, that one is equation number 3. Already we know that these are the two equations, and this one is a third equation, and V2 is equal to Z21 I1 plus Z22 I2. These two equations we are getting from this second equation only. Okay, already we know that matrix formation calculation. Based on that, we are taking here V1 is equal to I1 Z11 and I2 Z12. So that one is third equation, and here V2 equal to I1 Z21 and I2 Z22. So that one is fourth equation. So assume that the output of the two-port network to be a open circuited, I2 is equal to 0. That one is a fifth equation. Substitute equation 5 in equation number 3 and 4. So in 3 and 4 equations lo we are substituting I2 is equal to 0 in this sense. Then we can get V1 is equal to Z11 I1. From that we can get Z11 is equal to V1 by I1. And same I2 value we can put in fourth equation. Then we can get V2 is equal to Z21 I1. That is equal to Z21 equal to V2 by I1. Okay, so here already we got Z11 and Z21. From this Z11 and Z21 we got. Okay, then next time we are going to do a open circuit for next input port. It's mean assume input port in a open circuit, in the sense I1 equal to 0. So already I said whenever we are doing a open circuit, so open circuit condition voltage is very high and current is 0. So in any network we have two ports here. So suppose for example we are taking this network. So in this network we have two ports. This one is a port 1 and this one is a port 2. If we are taking V1 as a input at port 1, so at that particular condition we are doing a open circuit at port 2, then we can get two values. So at the same time input we are taking at port 2 and port 1 we can keep at open circuit. So here in the network we have two ports. So each and every condition, it's mean we have two conditions here. at one condition we are doing a open circuit at port 2 and another condition we are doing a open circuit at port 1. Okay, so in port 2 we are doing a open circuit, in the sense I2 current is a 0. So at that condition we are getting a 2 impedance values, and when we are doing a open circuit at port 1, then at this particular condition I1 is 0, then at this particular condition we are getting a 2 impedance values. So here I1 is equal to 0, that one is 6th equation. Then we can substitute in the same third and fourth equations. Then we can get V1 is equal to Z1 to I2, that one is equal to Z12 equal to V1 by I2, and V2 equal to Z2 to I2, Z22 equal to V2 by I2. So it's mean here Z12 and Z22 we got. So previously we got Z11 and Z21, and this time we got Z21, Z12 and Z22. So it's mean totally Z11, Z12, Z21, Z22 we got it because of the open circuit condition. So first condition we are going to take a practical diagram. So this one is a theoretical diagram. Here this one is a port 1 and this one is a port 2. These are all the resistances are unknown resistances. We don't know the impedance of these 3 resistances. We need to calculate these 3 resistances by using the voltage and current values. So it's mean we are measuring the voltage and current values, in the sense we can get V1 and V2 and I1 and I2 currents, in the sense then we can get these impedance values. Okay, so here this one is a practical diagram. In practical diagram we are taking input at port 1 side and we are doing a open circuit at port 2 side. Okay, and we are taking one ammeter for measuring the I1 current, and as well as where we are doing the open circuit, so at port 2 side. So at that particular place we are taking one voltmeter to measure the voltage value at port 2. Okay, at port 2 voltage value, in the sense that one is a V2 voltage, and at port 1 we are measuring the current value, in the sense that one is a I1 current. Okay, then here in case 1 open circuit second port I2 is equal to 0. So from that we got one tabular column. So it's mean V1 we are taking certain voltage value, so input voltage we are taking, and V2, so it's mean we are measuring V2 voltage by using one voltmeter, and V1 we are taking voltage, certain voltage at input side. Okay, so you remember, so it's mean this one is a supply voltage and this one is a output voltage. We are measuring that output voltage by using one voltmeter. Okay, then here we are getting current value. We are getting current value by using the ammeter, I1 current value. Okay, so we know these 3 values, in the sense we can get Z11 and Z21 value by using these 2 formulas. So already we calculated this Z11 and Z21 by using the open circuit condition. Okay, this one here Z11 and Z21. So that values only we are calculating here. Okay, so Z11 is equal to V1 by I1. So we got here 11.20 as a source voltage. Okay, we'll see in the practical circuit diagram. And we got current value I1 is a 50.11 into 10 to the power of minus 3. So from that we got Z11 impedance value is 222.22 ohms, and at the same time Z21 is equal to V2 by I1 formula. Okay, so from that V2 is a 7.5 volts, and same I1 as a 50.4 into 10 to the power minus 3, we got 48.80 ohms. Okay, then we will go for practical. So this one is a connecting diagram. Okay, So here this one is a DC voltage, so that DC voltage I am going to connect for this network, 2-port network. So positive terminal is connected for positive terminal and ground terminal is connected for negative terminal, and I have taken one ammeter here. So first terminal is connected for ammeter first terminal and second terminal is connected for second terminal, and as well as here I have done open circuit at port 2. Okay, so that's why across this port 2 I have connected one voltmeter to measure the V2 voltage. So first terminal is connected for first terminal of the voltmeter and second terminal is connected for second terminal of the voltmeter, and here no need a second ammeter at port 2 place. So that's why I have bypassed that ammeter value. It's a simple connecting diagram. So you can observe here from power supply to ammeter first terminal, ammeter second terminal is connected to next one, and voltmeter is connected at port 2 side. Okay, here we have done a open circuit actually. So for a power supply measuring purpose I have taken one multimeter here. So that multimeter I have placed at input side. So that input voltage I have interchanged, that's why I here showing a minus value. No, so 11.89 actually input source voltage. So it's mean input voltage in the sense that one is a V1 voltage. That V1 voltage only I have mentioned here 11.20. So previously when I was connected at the time I got 11.20, but this time I got 11.90. Okay, and V2 in the sense at port 2 side voltage. It's mean where we done a open circuit, that place voltage we are measuring by using the one voltmeter. That voltage is a V2 voltage. That V2 voltage you can observe here 7.5 volts. Okay. So, but previously when I was connected at the time also I got 7.5 volts only. Then this one is a one ammeter here. This one is a one ammeter. That ammeter value is I1 current. So that I1 current here I got 51.7. But here I have taken ammeter is a milliammeter. That's why 51.9 into 10 to the power of 3. So 50 previously when I was connected at the time I got 50.2. So 50.2 into 10 to the power of minus 3, because I have taken ammeter is milliammeter. That's why whatever the value we got, so that value into 10 to the power of minus 3. First case in the sense at the second port we done a open circuit, that condition only we have taken. That one is the first condition. And the second condition second case we are going open circuit first port. It's mean previous condition at port 1 we are taking power supply, but at this time we are taking port 1 as a open circuit. So at that particular place we can replace voltmeter, one voltmeter. That voltmeter voltage is a V1 voltage. Okay, and where we are taking open circuit previously, that place we are taking power supply. It's mean at port 2 side we are taking power supply. Okay, so nearer to that we are taking one ammeter. That ammeter value is a I2 current value. Okay, because port 2 place we are taking power supply, no, near to that current is I2 current. So here also same one ammeter and one voltmeter, but we can replace first port as a open circuit and second port as a power supply. And for first port place we are taking one voltmeter to measure the V1 voltage, and second port side we are taking one ammeter to measure the I2 current. Okay, so previously I have connected and I have taken values. So that values I am showing here 11.15 as a V1 voltage. So it's mean whatever the voltmeter we are connected at port 1 side open circuit place, and V2 voltage is a 8.7 volts, and I2 current we got here 59.1 into 10 to the power minus 3. We'll observe these values in practical circuit diagram. Okay, and from that we got we calculate Z12 equal to V1 by I2 based on this formula, and Z21 equal to V2 by I2 based on this formula. So according to values, Z12 equal to V1 by I2, so that is equal to V1 as a 11.15 by current I2 is a 59.4 into 10 to the power minus 3, that is equal to 188.98, that one has a Z12 value, and Z22 value is a V2 by I2 equal to 8.7 by 59.1 into 10 to the power minus 3, that is equal to 135.58 ohms. So completely we got here totally all the values, current and voltage values. Suppose for example here these are the final values. So previously first one formula we written here V1 and V2, Z11, Z12, Z21, Z22, I1 and I2, all the values we got eventually last end. Then we will go for second case connection. So first case directly I have connected, but right now I am going to connect one by one. So here the positive terminal is connected for second port positive terminal, and ground terminal is connected for negative terminal of the second port, and we are going to connect one ammeter at port to 2 place. Terminal is connected, ammeter first terminal is connected for first terminal, and second terminal is connected for second terminal, and here at port 1 side no need of any ammeter, that's why I am going to bypass it. Okay, and we need to take one voltmeter at open circuit, because previously we done open circuit at port 2 side, but here right now we are doing open circuit at port 1 side, that's why we are connecting one voltmeter at port 1 side. First terminal is connected for first terminal and second terminal is connected for second terminal, and I am going to take one voltmeter at port 2 side to measure the supply voltage. Then I am going to turn on. So this is actually connecting circuit diagram. These are the 3 meters. Then I am going to turn here. You remember power supply V2 voltage, it's mean whatever the V2 voltage we connected power supply, that voltage is same 11.85. okay, so but I have written here wrongly V2 as a V2 as a 11.84 actually. So this one is a input source supply we connected, and at port 1 output voltage we got it by using the 1 voltmeter, that one is a 8 volts, 8 volts, and current we got it here 61.60 or 61 point something, 61 or 60.9. so previously I have taken that one is a 59.1 into 10 to the power minus 3. This one is not changed, but here I have interchanged V1 and V2 values, so that's why once again we need to calculate Z12 and Z22 values. Okay, so these values will be interchanged because of these interchanging values. So Z22 as a 188.98 and Z12 as a 135.58. These two values will be interchanged because previously I have taken values are interchange values. So it's mean I have interchanged values I have taken previously. By mistake I have written. So that's why only V1 as a V2 value and V2 as a V1 value. So you have to correct it, that one. Okay, that one only a small mistake. and remaining is same, all the values we got it as it is, correct values, all 3 meters values. So this one is a V2 voltage, and this one is a V1 voltage, and this one is a I2 current. Okay.